Hello dear children, in today's video lesson of chapter number 15 probability, we are going to continue with the sums which are still remaining, and at the same time we will solve some of the solved examples which I felt are very important as far as the examination is concerned. So this is question number 23 from exercise 15.1. The question is, a game consists of tossing a 1 rupee coin 3 times and noting its outcome each time. Hanif wins if all the tosses give the same result, that is 3 heads or 3 tails, and loses otherwise. Calculate the probability that Hanif will lose the game. Now see what is given here. 1 rupee coin is tossed 3 times. Keep one thing in mind. A coin tossed for 3 times or 3 coins tossed together is one and the same. So when the coin is tossed for 3 times, what are the possible outcomes? Let's observe that. So when we toss 3 coins together, we get set of outcomes in this manner. Please observe this on the screen. All possible outcomes are flashing there, and you will see that the total number of possible outcomes are head, 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 tail, head, tail, head, tail, head, head, tail, tail, head, head, tail, 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 head, tail, and all the 3 tail. So if you calculate this, total number of possible outcomes are 8. Now what is given in the sum? It's given that Hanif wins if all the tosses give the same result. So in the possible outcomes where we have written, just check out where we are getting the same results. Here is one case and here is the other case. 2 times we are getting the same result, that is all the 3 heads and all the 3 tails. So out of 8 possible outcomes, there are 2 times wherein Hanif is getting the same result. So we can say that number of outcomes where Hanif loses the game is total number of outcomes minus the 2 outcomes, that is head, head, head and tail, 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 and if you calculate that, it is 6. So we need to find the probability. So let's make use of our formula. Probability that Hanif will lose the game is equal to number of outcomes where Hanif loses and total number of outcomes. Alright, so Hanif loses for 6 times and total number of outcomes are 8, and you can reduce it to lower term, and after that your answer is 3 upon 4, and that is the probability that Hanif will lose the game. Alright, so easy sum. Only thing is that the possible outcomes should be correct. Alright, moving ahead to the next sum. This is question number 24. A die is thrown twice. What is the probability that 5 will not come either time? So in the previous video lesson, I told you how to write down the outcomes when 2 dice are thrown together. So a die thrown twice or 2 dice thrown together, one and the same. And what are our possible outcomes? This many are the possible outcomes. And if you count this, the total outcomes are 36. We are asked 5 will not come up either. What is the probability that 5 will not come? Now let's find out where 5 is coming. So in this particular column, if you observe, one of the outcome out of the 2 die is 5. Here also we get 5. If you count all this, you get that the total outcomes where 5 comes up is equal to 11. And if we subtract this 11 from the total outcomes, then that will give us the idea about number of outcomes where 5 doesn't come up. So total outcomes where 5 will not come up is equal to 36 minus 11, and that is 25. Alright, but we need to find the probability. So let's use the formula. Probability that 5 will not come up either time is equal to total outcome where 5 will not come up upon total number of outcome. So we calculated that as 25 and total number of outcomes are 36. So 25 upon 36 is the probability that 5 will not come up either time. Alright, the sum has second part, and in the second part they have asked what is the probability that 5 will come up at least once. Now this particular word, at least once, so at least means either one time or more than one time. That is the meaning of at least once. So let's find out that. See now, we have total number of outcomes as 36 and total number of outcomes where 5 comes at least once, that we have already calculated. This is the place where 5 has come at least one time, and that is equal to 11. Now once you get the favorable outcome, finding probability is easy. So you just have to make use of our formula for finding the probability and find out probability of getting 5 at least once. And this is for your homework. You will complete the sum. Alright, moving ahead to the next sum. This is question number 24. Which of the following arguments are correct and which one are not correct? Give reasons for your answer. If two coins are tossed simultaneously, there are 3 possible outcomes: 2 heads, 2 tails, or 1 of each. 1 of each means head, tail, or tail, head. For each of these outcomes, the probability is 1 upon 3. So we have to just check out whether this argument is right or wrong. So when 2 coins are tossed together, the total number of possible outcomes are flashing here on the screen. Please have a look at that, and you will observe that the total number of possible outcomes are head, 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 tail, tail, head, and tail, tail. That is, number of possible outcomes is equal to 4. Now let's find out the probability, what is given there in the argument, getting 2 heads. So probability of getting 2 heads is equal to number of times we get the head and divided by total number of outcomes. Now if you see total number of possible outcomes, we are getting head only for 1 times. So 1 upon 4 is the probability of getting 2 heads. And if you check the argument, there it is written, the probability is 1 by 3. So this 1 by 4 is not equal to 1 upon 3. Let's check for the next thing which is written there in the argument, probability of getting 2 tails. So now these are the possible outcomes which are flashing there on the screen. Check there, we are getting 2 tails also just for 1 time. So our formula is number of times 2 tails occurs divided by total number of outcomes. Substitute the value, it is 1 upon 4, and this is also not equal to 1 upon 3. Let's check out the third thing which they have asked, that probability of getting 1 head and 1 tail. And if you see there in the possible outcomes there, we get 1 head and 1 tail for 2 times. So our formula is number of times 1 head and 1 tail occurs divided by total number of outcomes. If we substitute the value, it is 2 by 4. If you reduce it, it is 1 upon 2, which is again not equal to 1 upon 3. Therefore, the given statement is not correct. It is an incorrect statement, and the probabilities of these outcomes is not equal to 1 upon 3. So this is how you have to check the argument and check whether it is the correct statement or it is not a correct statement. Alright. Now this is a solved example, and I felt like this is really important and you should know this. Savita and Hamida are friends. What is the probability that both will have the same birthday, ignoring the leap year? Alright. So we all know that number of days in the year is 365. And number of days when same birthday is possible is 1. So out of 365 days, 1 day is the possible outcome wherein they will have their birthday. So probability that both will have the same birthday is equal to number of days where they can have same birthday in a year, and that is only one. Alright, and that is divided by total number of days in the year. So we'll write that 1 upon 365, and this is the probability that they will have same birthday. Now the second part of the sum, what is the probability that they will have different birthdays, and again ignoring the leap year. So their birthday will not come on the same day, they will have birthdays on different 2 dates. So again we have total number of days in a year as 365. We can solve this sum by using the formula P of E plus P of E bar is equal to 1, and then rearranging the terms and getting our answer. So probability that both will have the different birthday is equal to 1 minus probability that both will have same birthday, because we have just calculated the probability of both having the same birthday, so we can make use of this. Alright, so if we substitute the values, it is 1 minus 1 upon 365. Solve it. So 365 minus 1, this is by cross multiplication, divided by 365, and so we get the answer as 364 upon 365. So the probability that both the friends will have different birthdays is 364 upon 365. Alright. So next sum. This is again the example, and just have a look at that. A bag contains 5 red balls and some blue balls. We are not given the value. It's just said that some blue balls. If the probability of drawing a blue ball is double that of red ball, determine the number of blue balls in the bag. Alright, so let's see what is all given to us. The bag contains both red and blue balls. Number of red balls are given to us, that is 5. Since they said some blue balls, we'll consider number of blue balls as X. One thing is here that total number of balls. Now, because for finding the probability we need to know total number of balls. So we'll write total number of balls as 5 plus X. One thing is given to us, that probability of drawing blue ball is equal to 2 into probability of drawing red ball. And this is the statement which is given to us, and with the help of this we can find the answer for this sum. So let's see. Probability of drawing blue ball is equal to number of blue balls upon total number of balls in the bag. We have considered total number of blue balls as X, and total number of all balls including red and blue together is 5 plus X. So X upon 5 plus X. Then we'll find out probability of drawing red ball. So probability of drawing red ball is equal to number of red balls in the bag divided by total number of balls. We have 5 red balls and total number of balls are 5 plus X. Alright, now let's make use of the statement which is given to us, that probability of drawing blue ball is equal to 2 into probability of drawing red ball. Both the probabilities we have already calculated. Let's substitute the values. So we get X upon 5 plus X is equal to 2 into 5 upon 5 plus X. So we can cancel 5 plus X from both the sides. So what you are left with, X is equal to 2 into 5. So X is equal to 10. That means there are 10 blue balls in the bag. So this is one of the important sums, and you can consider this sum as higher order thinking level sum, that is hot sum. And with this sum we have completed our chapter of probability, and I suggest that please practice for this chapter, because now since some of the portion from our textbook is reduced by CBSE board, so the weightage for this chapter will increase, and it is easy to score if you prepare this chapter thoroughly. So along with this, you have got some sums for homework. These are the 3 sums. Please try solving it in your classwork and note it down. Find out the answer, and see you all in the next video lesson with new topic. Till then, bye and take care.